Hi and welcome everyone. So today I'm going to tell you about the significance of coenergy. Now first of all, what is a coenergy? So the coenergy is the energy stored in the magnetic field of an electrical machine. Just like the potential energy stored in the spring or the kinetic energy in the rotating mass, coenergy represents stored energy that can be converted into the useful work. So the coenergy is basically the energy stored in the magnetic field of the electrical machines. Imagine it as a battery that keeps the machine running smoothly. It is the hidden force driving electrical machines. See, when a magnetic field is established in the material, energy is required to create this field, and this energy is stored in the magnetic field itself. The coenergy is a known physical quantity. So coenergy is not just a theoretical concept, it is the driving force behind the motion and electricity generation in the electrical machines. Coenergy is expressed in the same units as energy and is especially useful for the calculation of magnetic forces and the torque in the rotating machines. The coenergy is zero for the systems that are incapable of storing energy. Coenergy represents the work done to establish the magnetic field and is directly proportional to the square of the magnetic flux linkage phi produced by the current flowing through the coils. Mathematically, we can express it as coenergy equals half the product of inductance and the current flowing through the coil. It tells us how much power is stored in the magnetic field. Here W is the coenergy, L is the inductance of the coil, I is the current flowing through the coils. See, inductance represents the ability of the coil to store energy in its magnetic field per unit current. The greater the inductance, the more energy the coil can store for a given current. See, by considering the coenergy stored in a magnetic field, engineers and researchers can better predict how magnetic materials will behave under different conditions such as changes in the current or the presence of the magnetic materials in the circuit. Coenergy is crucial in understanding the behavior of electrical machines because it affects their performance and efficiency. Coenergy is significant in understanding and analyzing the behavior and performance of the electromagnetic devices like motors and generators. In the electrical machines such as motors or a generator, there are the coil of wire bound around a magnetic core. When current flows through these coils, it generates a magnetic field in the core. This magnetic field stores energy, just like a spring stores potential energy when it is compressed. So the coenergy is useful for the calculation of the magnetic forces and torque in the rotating machines. In the motor, it powers the rotation, while in the generators, it fuels the conversion of the mechanical energy into electricity. So in the generators, it turns motion into electricity. See, motor operation. In a motor, electrical energy is converted into mechanical energy. When the motor is running, the coenergy in the magnetic field interacts with the electrical current, resulting in the production of the mechanical torque. This torque is what drives the motors. And second of the generator operation. In the generator, mechanical energy is converted into electrical energy. When the generator is rotating, an external mechanical force causes the shaft to turn, which in turn induces a current in the coils. This current generates a magnetic field, and the coenergy stored in this field is then converted into electrical energy. Optimization and efficiency. Understanding coenergy allows engineers to optimize the design of the electrical machines for maximum efficiency by adjusting parameters such as coil design, magnetic core materials, and operating conditions. Energy transfer can be maximized while minimizing losses. So by understanding and optimizing coenergy, engineers can create more efficient and reliable electrical machines. In the magnetic circuits, the concept of coenergy helps in analyzing the distribution of magnetic fields, understanding the interaction between magnetic components, and optimizing the design of magnetic devices such as transformers, inductors, and electric motors. By calculating the coenergy in the magnetic circuit, engineers can make informed decisions about how to improve efficiency, performance, and reliability of the magnetic systems. So this is about the significance of the coenergy. So thank you everyone for watching.